Okay, in this video I'm going to have a look at this pair of maps here, which are a little bit further along from the exhaust gas recirculation maps in this file. They're a fairly obvious shape, and so if you're used to looking at an EDC16 file, you can probably recognize straight away that they're almost certainly conversion maps for converting torque into injection quantity. Now there are two maps here, and if I remember rightly, further on in the file there are two more maps. It's quite likely that these two are for regeneration and the two further on are for normal engine running, or it could be these are for normal running and the two further on are for regeneration. You just have to look at the value, because generally speaking the regeneration values are lower, so you can work out which maps are which from that. And we've got two, which suggests that there might possibly be two different types of engine conditions available for the operating system. I'll just look at one. Now again, these are very often found by winnows, so it's quite possible that this will be found by winnows with a little box around it saying that this is a potential map. Now if I just double click this one, what we've got then is engine speed down the side. Again, if we look at it in its original form, you can see it originally ran to 9,000, so quite a high number, so it's almost certainly going to be engine speed. Along the top we've got something that could have been engine speed because it's gone up to 4,200, but because this is an EDC17, by the time you put the factor of 0.5 in, that would bring the engine speed down to 2,100, and there are not going to be many files with an all-out maximum speed of the engine of 2,100, and so the chances are that this will be either injection quantity or torque, and as this is probably the torque to injection quantity map, then these values will be torque. And as before, if I click on there, the factor is 0.1, so we've got torque Newton meters, factor of 0.1, which gives us our maximum torque up to 420. And so here we've got the output in milligrams per cycle or milligrams per stroke, and so they will have been originally 7030, that sort of number, so we would have had quite large numbers, or that one there would have been 7300, but by the time we put in our factor of 0.01, that gives us a value of here 73. So we've got 73 milligrams of fuel being injected, so 73, 71, 70.8, so there's our fuel being injected. So what this does is basically translates what's going on in the driver's wish map, because if the driver's wish map says for this particular amount of pressure, let's say 80% pressure on the pedal, you will get, let's say, 300 Newton meters of torque, then now for a given speed and 300 Newton meters of torque, we can see how much fuel we would need. So we can say to ourselves, well, let's have a look. 300 at 3,000 revs and we need 48.1 milligrams of fuel. So 48.1 milligrams of fuel at 3,000 revs per minute should give us 300 Newton meters. So that's basically what this map is for. It's just translating one thing into another. Now the ECU reads it one way, but obviously you can read it another. I mean, you can look at it and you can say to yourself, if I've got this much fuel, I get that much torque. The ECU will not read it that way. The ECU will look at it and match speed to torque, and then the output will be injection quantity. But because we're human beings, we can look at this any way round we like. Now this one will be the same, so if I open up this one, it's all the same. The figures might be very slightly different, but basically it's the same. So we've got two torque to injection quantity maps, very similar to EDC16, the only real difference being that the engine speed uses a different factor. So very, very simple. Right, I'll stop at that point for that one.